Hi, Internet. That's what we're going to find out about today. Christiane Ruetten is going to tell us all about it. And I've got a few questions to you. If you bought day passes, day 1, 2, and 3, you're going to get the 4th for free. So please bring your bracelets, and the 4th day you're going to get them for free. We'd like to challenge you to give us a bit of feedback. You can do that on our webpage with Christiane's talk. And in the schedule, click on it, and then you can click on feedback. But you can also do it on Twitter, for example, using the hashtag 26C3. And use also the hashtag P4ULA, Paula, so we know that it's about this talk. Thank you very much. Well, good luck. I'm really
Thank you.
Wondering what you're going to talk about.
Yes, okay. Hello, everybody. Yes. It's great. Thanks a lot. But just wait until afterwards. So it's always very exciting to speak to you, to so many eager minds. So let's have some fun. So first thing, when I was preparing for this talk, and doing the research and trying to find sources for some of my assumptions and all that, I basically came on one paper by Dr. Martin Warnke. He is a scientist at the University of Lüneburg in Germany, and he pretty much dealt with most of the basics I'm trying to cover. And so there's one thing that struck out to me, and it's pretty much this passage of his introduction. There's a problem with hard science because, well, it basically says here, I'm just going to read it out, and just because there's a very different degree of certainty where we can prove, or at least convincingly affirm, like in the hard sciences, this certainty comes at the price of being unable to talk about those things that cannot be proven or computed. And these are the things that are actually happening in the sphere of society, culture, and contingency. And so that's my point. So don't take this too seriously. Let's have some fun and see where this leads. So the first thing, and this is pretty much along with Warnke, he defines the development of our information culture, of our informational systems, by 3 stages. And the first of the stages was just when the early computers came into existence, and they were mainly used for synthesis. That means you give the computer some instructions, and then it starts computing a pretty picture, line art, or whatever, and it just does pure synthesis. It's totally computable, and it's what Turing's machines do. The little TMs, those are the Turing machines. So the next step came when the computers became more powerful and the interfaces became more human-like and better adapted to the humans, and the output got better consumable by humans. The realism started to increase. That was the mimetic phase. That means people started using the computers as tools for, well, let's say, generating animations and generating or doing interactive arts and this. So when you look at this diagram, you will see lots of Turing machines and people communicating with those Turing machines, and those Turing machines are networked, well, pretty much today as the internet among each others. So once you start with people, or let's say individual minds in such a network, you will have what is called contingency in there. That means the contingency means you get some factors in there that are either true or false, but may well be somewhere in between. So let's call it uncertainty in a broader sense. And there's another thing in these networks that can be observed that's called the autopoiesis. And that basically means the system wants to, well, creates itself and preserves itself. So, and what this leads to is the latest stage that we are seeing today. It's the emergence stage. So that actually means the systems that we're using and we're part of today cannot be explained by the sum of its parts. So there's even more to it. And, well, just to grab ahead a little in the talk, when you look at these graphs and the constituents in there, and you will take a broader look from far away, it will all shrink down to one node. And this node, let's say we're looking at a bunch of Facebook users here using their computers, which are networked. And when you look at it from far away, it will appear as some Facebook individual and acting with its environment. So this is the self-similarity aspect of those graphs. You can zoom in, you can zoom on the people, and you will see they contain of cells, they're constituted of cells, and so on. So, just to keep it in mind. And it was Luhmann who actually, one of the system theorists, who actually came to this conclusion. When you say there's autopoiesis, and the system creates itself, then emergence is not just accumulation of complexity of the constituents, but it's a break and a fresh new start. And what this actually means is that the systems that are generated from some constituents of some complexity do not necessarily inherit the complexity of the constituents. So a very vast system of communicating people and machines can have much less complex characteristics than, well, the humans inside of it. So this is one example of emergence. There's a German website and let's say it's a news portal, mainly that has a forum. It's from the news portal of heise.de. And they've got a forum. And this forum, it has several threads where the people, well, say whatever they want on the topic. And this was on the topic of, well, it's some kind of fashion. Each year there's some farewell wishes for Christmas and New Year. And this was the response. I mean, this is pretty, you would expect that. There's lots of, oh yeah, nice work, and we wish you a pleasant New Year and all that. That's pretty standard. But what right away struck me was this here. I mean, this is actually the system used for voting on the quality of what the people write in the forums. And it's pretty much known that there is some kind of green wave going on when there's a topic discussed that generally is appreciated by the people in the forum. It all goes green. That's a green wave, whatever people say there. It's all, the red wave is known as well. It's when they totally disagree with what's in the topic. So, but this is an alternating pattern suddenly emerged. So it isn't even possible that one person started this, because you need to have at least 10 positive votes to get it into the green, or 10 negative votes to get it in the red. But somehow people got it, that it was like that. I mean, it's pretty fascinating. It was just emergence going on. Cannot explain it by what individuals do. So if we're looking at what's happening in our brains and in our networks, it's one of the most basic networks we have. It's constituted of biological neurons. And basically, these do have some very similar features like the networks we are used to in the internet. There's some inputs, definitely, and that's the dendrites. That's the fluffy part going on here. And you've got the axons. These are the outputs. These are the thick ones. And they will somehow crawl around the brain and find a dendrite to actually connect to. And what goes on in such a network is nothing more than just electrical impulses. That's pretty simple stuff going on there, but there's quite some emergence going on. And if you want to understand what's going on there, you just need some sort of model. So this is where the artificial neurons comes in and neural network theory. And this is pretty much what, well, can be used for modeling neural networks.